In this session, I intend to go through some basic calculations pertaining to how you measure rates of return. Some of this is really basic, perhaps even at the high school or lower level, but part of its intention, that's why it's called review and more, is to sort of get us all on the same page in terms of how we view performance of different types of investments. So with that said, let's take a look at rates of return and more. The most obvious thing, the basic thing, is to think in terms of an investment of $100 that compounds over a period of 1 year to a value of 120. We all know how to calculate a percentage rate of return. In this world that we are now learning to live in, it's sometimes called an HPR, or a holding period return, and it's basically just a percentage change from 100 to 120 in whatever units you want to think about it: rupees, dollars, other currencies. The obvious connection to basic finance notions that most of you should be familiar with is of time value of money. Think of the 100 as the present value, the 120 as a future value, 1 as the time frame over which this investment was made. Obviously 20% is the rate of return that accrued over this period of time. Let's skip to the next slide, where in addition to just having a price appreciating from 100 to 120, there is also a cash flow called a dividend of $5 that is paid, or 5 rupees that is paid at the end of this period. How does that affect the rate of return? What that does is, all you have to do is to add it back into the holding period rate of return calculation. The 5 goes back in here, and now instead of 20%, which was the previous part, there is an additional 5% incremental growth, so you have a 25% rate of return on this thing. The common way in which people think about this is to think of the price appreciation part, the 120 to 100, as a capital gains return or a capital gains yield, and the 5% as a dividend yield. If this was not a stock but it was a bond, of course it would be a coupon yield instead of a dividend yield. But that's how you kind of decompose the 25% rate of return into its two component parts. What if this period was not a year? What if it was less? There is a process of annualization. That is also something many of you have learned about. I'm moving this along as quickly as I can because I'm guessing most of you know how to do this. In the annualized rate of return idea, let's say you've agreed to borrow $9,900 and repay $10,000 in a month. Obviously, you've paid $100 in interest at that period. How do you convert that 1 month's interest into an annual rate of return, and why do you do that? If you convert it as a percentage the way we just saw how to do it, it's actually 1.01% holding period for a holding period of 1 month. To convert it to an annual rate, do you just multiply it by 12? Or do you compound it over 12 months? The APR, which is what most credit card companies like to quote for you when you borrow money, and remember how credit card processes work, you typically repay at the end of each month some portion of your balance. The APR requires you to just multiply by 12. If you compound instead, it means you're paying interest on interest. Then the EAR, or the equal annual rate of return, is a little higher. The APR is what credit card companies like to tell you, just because it is a smaller number. Your effective rate of return, if you don't pay out your full balance on the credit card at the end of each month, is actually what the EAR says it will be. Notice there again how the numbers show you what happens. The HPR was 1.01% for that month. Multiplying by 12 gave you the APR of 12.12%. The effective annual rate, where you're compounding the 1.01% over 12 months, and that's kind of a compounding formula that you all know already, that gives you a return of 12.82%. In the credit card world, that is interest charged, it is your cost. Obviously, credit card companies would rather show you a lower number as a cost of the APR rather than the EAR. But whatever it is, the EAR is assuming that you're compounding interest on interest. And this is a concept that you guys are pretty much familiar with, I would think. How do you go to multiple periods of return? Would be the next question that comes along, right? So go back to my initial example. You started with a $100 investment at the beginning of time 0. 2 years later, it compounded to $121 or 121 rupees. The compounding formula basically says that you have to compound at some rate of return X over 2 periods. X works out to be 10% per year. That's your annual rate of return or a holding period rate of return for a 1-year period. It could come in different pieces. The money does not, I didn't tell you in the first slide what happened in the intervening period in the middle here, but supposing it appreciated by 8% to 108 the first period, and then to 121. You have 8% returns in the first period here, and 12.04% returns in the second period. compounds to 21, but the 21 is decomposed into 8 for the first and 12 for the second. That's how kind of multi-period stuff works. So do you take averages then to get back from a multi-period setting of 21% to a single period setting of 1 year? The arithmetic average is 10. The geometric average, which is just another way of averaging things, is to take the two individual return pieces, take a square root because it's averaging over time now, and take out the 1 because you start with the $1 in the beginning. That's a return of 10% as well. The usual practice in this business is when you're trying to find averages across time, you use a geometric average. If you're doing averages at the same point in time over different groups of stocks, then it's okay to use the arithmetic average. Which is correct? Take a simple example and you'll see why the geometric average makes more sense. Same kind of situation, you have a $100 investment at the beginning, it actually lost half its value at the end of a year, and then it doubled. The first year your return was a negative 50%, the second year your return was 100%. You take an average, the geometric average of the 100 and the 150 gives you, the arithmetic average gives you 25%, but really you didn't make any money over that period. The 100 stayed the same. The geometric average is the correct one. And you can think of that as a proof that the geometric average is the best way to average returns over time.